A quadric surface is a function considered the 3D equivalent of 2D conics like circles or parabolas. The general equation is given by where a through j are constants that can tune the surface scale, orientation, or curvature. By manipulating and combining quadric's equations, we can approximate representations of real world objects. Here are some shapes we all know and their equations. First, we have ellipsoids, which can represent spherical objects if A equals B equals C. We also have cones, and we have cylinders. Since z is missing from the equation, z is then defined as all real numbers, which is why the cylinder travels continuously up or down on the z-axis. We're going to start with the elliptical paraboloid, which is shaped like a bowl. To model a hill in my neighborhood, I'm going to flip the paraboloid upside down by making z negative. And then I'm going to shift it up by adding a constant c, which represents the max height. By adjusting A and B, I can make the hill broader or steeper. Because my hill has a gentle slope, I'm going to increase Y by increasing B. So I get like a more gentler slope upwards. And since elevation is always positive, I'm going to bound Z to be greater than or equal to 0. Ultimately, we get this. It's a simple yet effective way to model natural landscapes. For more figures, we also have a parabolic sheet, which looks like a piece of paper. We have a hyperboloid of one sheet, which looks like a funnel. We also have a hyperboloid of two sheets, which is separated in the middle. And we have a hyperbolic parabola, which looks like a saddle or a Pringles chip. Of course, real world objects are much more difficult to describe using just one quadratic surface, no matter our transformations. Thus, we can overlap these 3D objects to model more complex figures, like my lamp base, which is a hyperboloid of one sheet intersected by an ellipsoid. Whereas the other quadric surfaces have defined equations, how do we mathematically represent these combined surfaces with unclear equations? In 3D computer graphics, we can use constructive solid geometry, which uses Boolean operators to combine simpler objects to generate visually complex objects, such as the following. Using the Boolean union operator, we can merge together two objects into one. The notation is where the function of A and the function of B are the two surfaces we are overlapping. Using 3D equations to model real world shapes is incredibly important and used in many different disciplines. For example, architects can use 3D shapes like cubes, cones, and pyramids to build complex models of building and software.